All right, so these are the questions from the Section 7 Quick Check. So first it says to identify the information given the geometric sequence. So we have this geometric sequence. We know that it's geometric because as we go between the terms, there is multiplication happening. Remember, arithmetic, there's addition or subtraction, but between these for geometric, there's multiplication. So 3 times 2 is 6, times 2 is 12, times 2 is 24. My a sub 1 means my first term, so in this case that is 3. And my r is my common ratio. So a sub 1 is your first term, and r is your common ratio. And so my first term here is 3, and my common ratio is 2 because that's what's being multiplied. Now, my explicit formula, these blanks are forever long, but I'll write it right here, is 3, my a sub 1, times r, which is my 2, to the n minus 1. It's always to the n minus 1 power. So in these parentheses, it would have been 3 on the outside, 2 in parentheses to the n minus 1. So this blank would have been 3, this blank would have been 2. We could use that to help us find a to the 22, or sorry, a sub 22, which would be 3 times 2 to the 22 minus 1. So 3 times 2 to the 21st power. So if we were to figure that out, that would give us, let me grab a calculator. All right, that would give us 2 to the 21st power would give us this times 3 would give us, and it says no commas, so 6, 2, 9, 1, 4, 5, 6 would have been your correct answer there. Okay, if you did put commas, then we did go back and give you credit, so just be careful, make sure you're paying attention to directions there. So here we go, question 2. So question 2, this is question 2. The first term of a geometric sequence is 2, and the common ratio is 3. What is the 8th term of the sequence? So we have a sub 1 is 2, and r is 3. So we can write, because it's geometric, we can write a sub n equals a sub 1 times r to the n minus 1. So then a sub 8 would be 2 times 3 to the 8 minus 1. So 2 times 3 to the 7th power. So then we have 3 to the 7th power times 2 gives us 4,374. Should have been my 8th term of that sequence. Okay, so then question 3 says which of the following is a geometric sequence? Remember that a geometric sequence means that the numbers are being multiplied by something to get to the next number. So 3 to get to 8, if I were to divide 8 by 3, I get 2.666666666, but 8 times 2.6 repeating will not give me 13 because that would have to be at least 16. So that's not a geometric sequence. I'm not sure what's going on here with this one. I don't know if it's supposed to be 1/2 and then 1 3/2. Not sure what that was supposed to be. So that one's just weird. That's probably not my answer. I could check this one. -2 to get to -6 is times 3, but -6 to get to -10 is not times 3. This would actually be an arithmetic sequence because we're subtracting 4. So -4, -4, -4. This one's arithmetic. So this must be my answer. Times 2. 5 times 2 is 10. Times 2 is 20. Times 2 is 40. That is a geometric sequence. Continuing on to number 4. Which graph models the exponential function y equals 3 to the x. Now remember that y equals 3 to the x is the same thing as y equals 1 times 3 to the x. So my y-intercept is 1. So it's going to go through the point 0, 1. And then my common ratio is 3. So as I go over, I'm multiplying by 3. So I could make a table even to show my point 0, 1. And then at 1, it'd be at 3. And then at 2, it'd be at 3 times 3, which is 9. And then at 3, it'd be at 9 times 3, which is 27. And then if I went backwards, at negative 1, it'd be at 1/3 because 3 to the negative 1 would be 1/3. At negative 2 would be at 1/9. So it looks like my asymptote's going to be at 0. Okay, because it's not adding or subtracting anything here. It's not shifting up or down. So it should go through the point 0, 1. That's my first thing I need to check. And then it should also, so I'm not sure where my other graph on this one went. Hang on just a second. So my other graph didn't print for some reason, but this graph also fell this way. So it's, it had a, has an asymptote there, but it falls and it's decreasing as well. And we know that if it's multiplying by 3, these are increasing. So 1 times 3 is 3, times 3 is 9, times 3 is 27. It should definitely be an increasing graph. So we could X both of these out because both of these graphs were decreasing. So then if we look at these, the only one that's crossing at 1 would be A, or this graph. Now I could double check and make sure that it goes through the points 1, 3. So 1 is here because that's 2. So that's 1, 3, and 2, 9, which would be further up here. Looks like it's headed for that. And then it also does approach 0. So at negative 1, it's at 1/3, and negative 2, it's at 1/9, then it is approaching 0 in the same way. Whereas this one at 0 is at 2, and 3 to the 0 is 1, not 2. So it would have to be A. Continuing on to question 5. So this is question 5. Which of the following shows the table representation of the exponential function f of x equals 5 times 2 to the x? So you could do this one of two ways. You could say, okay, I know this A value is my y-intercept, so I'm looking for the point 0, 5. If it's 0 anything else, then that is not my answer. So that has the correct one. You also could just sub in the points. So put in 1, so 5 times 2 to the first. So that's 5 times 2 to the first. 5 times 2 is 10. 5 times 2 to the second. 5 times 4 is 20. And so that's 110, 220, and then 5 times 2 to the third. That's 5 times 8, which is 40. So all 3 of these points check out, so that's my table. Whereas it looks like this one is adding 5, doing the correct exponent, but adding 5 every time instead of multiplying. And we know that this right here means that I should be multiplying. Question 6, moving right along. The following table represents an exponential function. The exponential function represented by the table can be written in the form y equals a b to the x. Find the values for a and b. Now remember, a is my y-intercept. So if I'm looking for my y-intercept, that's where x equals 0. So if I look at this table where x equals 0 is 4, so my value of a is 4. And then my b value is my common ratio. Okay, so it's the same thing as my R or my common ratio. So in order for me to find that, I need to see what's being multiplied every time. So if I look here, to get from 4 to 2, I have to multiply by 1/2. From 2 to 1 times 1/2, 1 to 1/2 times 1/2, 1/2 to 1/4 times 1/2. So every time I'm multiplying by 1/2. Okay, so it doesn't ask you to do this, but if it did ask you to write this function, remember that would be y equals 4 times 1/2 to the x. Okay, question 7. So this one's similar to the last one it just gave us, but y equals 4 times 1/2 to the x minus 1 minus 2. So again, here I'm just making a table to help me. I can identify some things that might be true about it, but I want to make that table just to make sure. So I have x and y. First number I'm going to put in is 0 because I want to know where that y-intercept is. I want to know where it crosses the y-axis. So I'm going to say 4 times 1/2 to the 0 minus 1 minus 2. Okay, the 0 minus 1 is -1. So 4 times 1/2 to the -1 minus 2. Now, one thing that I've noticed that a lot of us are forgetting is how to work a negative exponent. Remember, the negative exponent simply flips my fraction. It gives me the reciprocal. So instead of 1/2, the reciprocal or the flip of that would be 2 over 1. So I have 4 times 2 over 1 minus 2. 4 times 2 is 8. 8 minus 2 is 6. Now, if you want to type this in your calculator exactly like this, that's okay. Just make sure when you do the little exponent key, you put 0 minus 1 in parentheses so that it knows that that entire expression is the exponent. So for 0, it's at 6. So 0, 6, I can go ahead and graph that one. And then I have the point 1. So 4, let's come down here. 4 times 1/2 to the 1 minus 1 minus 2. 1 minus 1 is 0. So 4 times 1/2 to the 0 power minus 2. Now, any number to the 0 power is always, always, always 1. Please don't say 0. 4 times 1 is 4. Minus 2 is 2. So I have 0, 6, 1, 2. Okay, so I'm starting to see this is going to be a decreasing function, which makes sense because this r value is less than 1, so it's decreasing. At 2, it's going to be 4 times 1/2 to the 2 minus 1 minus 2. So 4 times 1/2 to the first minus 2. So 1/2 to the first is just 1/2. 4 times 1/2 is 2 minus 2, which is 0. So the point 2, 0. And then if I go to 3, I have 4 times 1/2 to the 3 minus 1 minus 2. So 3 minus 1 is 2. So 4 times 1/2 to the second minus 2. So that's 4 times 1/4 minus 2. So that leaves me 4 times 1/4 is 1 minus 2 is -1. So that's 3 -1. And then 4, we'll do one more this way. So 4 times 1/2 to the 4 minus 1 minus 2. So 4 times 1/2 to the third minus 2. So that's going to give me 1/2 to the third is going to be 1/8. So 4 over 8 minus 2. So that's 1/2 minus 2, which is -1.5. And this is where we're going to start seeing it slack off to have an asymptote at -2. So this is my asymptote. Okay, so we're going to approach that, but not cross it. Now, if you wanted to be super accurate here, you could even go to -1 and sub that in. So it was at 4, -1.5. You could even go to -1 and sub that in. So you have 4 times 1/2 to the negative 1 minus 1 minus 2. So that's 4 times 1/2 to the negative 2 minus 2. Now, 1/2 to the negative 2, I'm going to flip it and square it because the negative tells me I flip it to 2, and then 2 squared is 4. So that's 4 times 4, which is 16, minus 2, which is 14. So it should be at negative 1, 14. And then it comes down from there. So check your graph. If you got 0.5 or 0.75, something like that, then it's probably that you got some of the points, but not quite all, or you got most of the points, but you didn't quite get this asymptote. So check your points, and then you'll see where your partial credit came from there. So that was question 7. Let's look at question 8. So question 8 is going to use this graph. So more than likely, if you got the graph correct, then you probably got question 8 correct. But if you missed something on your graph, you might have missed this part. It kind of went together. So describe the end behavior for the previous graph. So as x approaches infinity, y approaches. So as x approaches infinity, so that's from left to right, as x is approaching infinity, y is approaching negative 2 because there's my asymptote. It's starting to level off there and approach negative 2, but not actually be there. So that one should have been negative 2. And then as x approaches negative infinity, that's as x decreases, y is approaching infinity. Y is approaching positive infinity because it's going up from right to left. As x is decreasing, y is approaching infinity. So infinity should have been my answer there. Okay, question 9. Match each graph with the correct exponential function. So I have a set of exponential functions here that I can look at to put with each graph. Okay, so if I look at this one, I know that it crosses at 4. You could type these in your little yellow calculator to help you find it that way, or you can just kind of go with each one. Now, be careful, one of these we just graphed, so that might have thrown you off a little bit, but one of these we just graphed 4 times 1/2 to the x minus 1 minus 2. We had just graphed because it went through at 6, so that would be this one right here. Went through at 6, and then at 14 is where it crossed there, and then went through at 2. So this would be that f of x equals 4 times 1/2 to the x minus 1 minus 2. So that one's taken care of. We had just done that one. Now, I would probably go to these two next and eliminate them a little more easily because these should go by 4. They should both cross at 4. Except for I know because of this 2, this one's going to be increasing, and this one's going to be decreasing because this 2 is bigger than 1, and this 1/2 is less than 1. So they're both going to cross at 4, but one is increasing and one is decreasing. So this one crosses at 4, this one crosses at 4. The one that's increasing is going to be f of x equals 4 times 2 to the x because it's going up, it's doubling. And you could check that by saying it's at 4, now it's at 8, now it's at 16. And then when I go this way, it's at 2, and then half of that is 1, and then 1/2, 1/4, and so on. Now this one, the other one that crosses at 4 down here, does the opposite. As it goes over, it halves, so it's multiplying by 1/2 every time. Okay, so it's at 4, and then it's at 2, and then it's at 1, and then it's at 1/2, 1/4, and so on. And as it goes this way, it's opposite. It's 4, and then 8, and then 16, and then 32, and so on. Okay, so it's the opposite of this. Now this one, I have f of x equals 3 times 2 to the x minus 2 plus 2. Okay, so f of x equals 3 times 2 to the x minus 2 plus 2. This one is different in that we would need to look at a table to tell exactly where this one crosses. So I know that if I put in 0, that would tell me my y-intercept. So if I put in 0 here, I have 3 times 2 to the 0 minus 2, which is negative 2, plus 2. So that's 3 times 1/4, because 2 squared is 4, but it moves it to the bottom, plus 2. So that's 2.75. So that's probably a pretty big indication that that's going to be this one, because no other one crosses at 2.75. You can continue to plug in points. If you put in 2, you should get out 5. If you put in, you could put in the other points and check and see where it's at. If you go this way, you're going to see that it is approaching 2, has an asymptote at 2. Okay? So that was question 9. Question 10, we actually ended up treating as a bonus. So I will kind of walk with you through it just to explain where it comes from. I think that this week, as we go through transformations on a graph, this will become a little more apparent to you as to how we get it, where it comes from, some hints you can take to write the equation, things like that. But let's just start with looking at this graph and noting some things. So I see a couple of things. I see that the asymptote was at 0, but now it's here. So that tells me that this graph shifted up 1. Well, if we think back to our transformations, okay, which we're going to review on Tuesday of this week, but if we think back to our transformations, in our transformations, if everything shifts up 1, then that means out beside whatever my function is, there's a plus 1. So, for example, if we had y equals a times b to the x, there would be a plus 1 out here. So if there's a plus 1, let's make a table of these points to help me out a little bit of what I have right now. So right now I have the point 0, 2. I have the point 1, 5. And then I have the point 2, it looks like 17. That one's a little tricky to tell whether it's 16 or 17, but I'm going to say that it's still to the left here, and then it goes up and it crosses at 17. Now that is a little tricky, but I would say it does. And then when I go this way, it's approaching 1. So these are going to be some decimals here. Now, if I know that it shifted up 1, okay, that it moved up 1, if I take 1 away from each of these coordinates, okay, so let's shift it back down basically. I have 0, 1, okay, 1, 4, and 2, 16. So now that we've gotten that plus 1 out of the way, let's analyze what's happening here, okay? So here, I have 1 times 4 is 4 times 4 is 16. So that would mean that my common ratio is 4, and then I'm adding 1. So that would be the equation y equals 4 to the x plus 1, which some of you got and got bonus points for. But if we needed to test it, 4 to the 0 is 1 plus 1 is 2. 4 to the first is 4 plus 1 is 5. 4 to the second is 16 plus 1 is 17. So we kind of have this same idea going on of it's multiplying each time by 4, okay? However, this plus 1 shifts it up. So it's multiplying by 4 and then adding 1. Multiplying by another 4 every time and then adding 1, okay? Again, that was a bonus, but by the test this week, we should be able to do this because we're going to talk about transformations on Tuesday. That should be helpful for you. So let's continue on to question 11 and 12. So 11 and 12 kind of lowered the difficulty back down after 10. So let's look at 11, which represents the function used to find any term x of the sequence 2, 8, 32, 128, and 512. So if we're talking about sequences, we have to decide first, is this geometric or arithmetic? So as I'm going through here, plus 6 is not 32, so it's definitely not arithmetic. To determine whether it's geometric, 2 times 4 is 8, times 4 is 32, times 4 is 128. So it's multiplying by 4. It has a common ratio. So because my r is 4, it is geometric. My a sub 1, or my first term, is 2. So when I write my function, I have a sub 1 times r to the n minus 1. In this case, because it's f of x, we replace that n with x. So 2 times 4 to the x minus 1, which is this one. And then which ordered pairs are on the graph of f of x f of x equals 4 times 3 to the x. So I could sub in each ordered pair to determine which one is true. So if I put in -1, I have 4 times 3 to the -1. So 3 to the -1 is 1/3. That's 4 times 1/3, which is 4/3. So this is on that graph. 4 times 3 to the first. So 3 to the first is 3. So 4 times 3 is 12. So this one's on the graph. 4 times 3 to the fourth. So I could say 3 to the fourth here. So I can say 3 to the fourth. That gives me 81 times 4 is 324. So that one would be on the graph as well. 4 times 3 to the 1/2. You also could put that as 0.5 if you wanted to put it in your calculator a little more easily. 3 to the 0.5 power is kind of like the square root of 3, so it's going to give you a really weird number. It actually is exactly the square root of 3. Times 4 does not give me solid 6. It gives me like 6.928, whatever. So that one is not on my graph. And then 4 times 3 to the second. Well, 3 to the second is 9. 4 times 9 is 36. So that one is not on my graph either. So all three of these are. Your answer choices might have been in a different order, but those are the 3 ordered pairs that were on this graph or work with this equation. So if you have any questions, let me know.